Very good morning. Today we are going to see about the what is meant by optimization. The previous classes we have seen enough examples about the optimization techniques and how the living creatures, they are optimizing their life like that we have seen in detail. So now we are going to see about what is optimization and how to relate that optimization with your techniques. That is electrical engineering. Like we are going to deal with economics of power systems. No, so in that, so every objective function has its own objective function and every optimization problem has its own objective function as well as the constraints or limitations. Okay, objective function and constraints. So each and as I said, the students also have some objective function and some constraints. So students objective function is to get very good marks in the exam. So their constraints is that they need to study 1 hour in a day or 2 hours in a day. Like that, constraints are there. So not only one constraint, there are many constraints are there. So for getting their degree, they need to study 5 subject, 6 subject, then two or three laboratories. Like that, many constraints are there. Okay, so every problem has its own objective function as well as the constraints. So sometimes the objectives might be of multi-objective. So there will be not one objective. There might be some multi-objective. Okay, sometimes students' objective might be they need to get very good marks. They need to get placed in very good companies. They want to settle in the life very soon after completing this degree. Like that, many objectives might be there. Some students might have like opting the like postgraduate studies in foreign countries. Then their dream universities might be there. Maybe that might be their objective. Sometimes some students might have some dream companies. They want to get it into this particular company only. Okay, so like that, many objectives are there. Okay, not only in software sector as well as in core sectors. Like that, many objectives are the constraints they need to work on to that. Okay, so whatever they might be the objective, they need to work on to that within certain period of time. Maybe 6 months of time they need to do an internship. 6 months of time they need to do study for that particular exam. They have to clear that exam. Then they clear the entrance exam. They need to get that particular job or particular post. Like that, some object constraints might be vary. So the objective might be of multi-objective and multi-constraint. Okay, like many problems if you take, it may depends on the problem to problem. Okay, sometimes multi-objective may become constraints might be of very less. Sometimes objective might be more and constraints also more. Then the complexity also more. Okay, so as I said, very simple example. So in engineering, in designing a product or designing anything, so in that scenario, if you want to solve multi-objective problem and with a multi-constraint, then the complexity will be very more. If it is a very single objective and the constraints are of two or three, four, 5 types, then the complexity of the problem is somewhat medium. If it is one objective and one constraints or two constraints, then the problem is very simple to solve. But practically speaking, if you take any problem, the objective might be of multi-objective. The constraints also multi-objective. Okay, so very difficult to solve. Okay, very difficult to solve. You have solved certain problems in your mathematics, like linear problem or non-linear problem, non-linear programming techniques. I think in mathematics 1, I think you have mathematics 3, you have solved this problem and a non-linear problem, linear programming method and non-linear programming method. And in control systems, in the subject control system also, you might have studied this linear programming and non-linear programming. So what in linear programming method, how they did is, they might be in linear programming method, that might be of like you might be solved a certain problem like one objective, and the constraints might be of two, like that you may solve. And that too, for solving that problem minimum, I think you might be taking um, half an hour. Half an hour minimum you might be taking for one objective and two constraints. Minimum half an hour you might be taking for solving that problem. Okay. So sometimes in the same thing, non-linear problem also you ought to solve. But what is the assumption you did in that solving the non-linear problem? You considered that non-linear problem to be linear, and you might have solved that problem. I think if you don't remember, you go across like you go and re-verify your mathematics 3 subject, then you come to know, like whatever the problem you solved is only linear. So non-linear problem also sometimes in the question they might be asking. So the very first step what we did is, we just write one assumption like this, though even though this problem is non-linear problem, we assume that problem as a linear problem. Then we are going to solve the problem like that. One line you written, and then only you solve, even though the problem is non-linear. Why? Because non-linear problem is somewhat complex to solve, and that it might be taking more time. It might be taking more time. The objective are of many things, and the constraints also of many things. Certain constraints, I think while solving also in control systems, certain constraints we neglected and we solved the problem. I think you come across the in the solving the control system also. Then mathematics also say certain constraints what we did is we neglected, even if they ask the problem like 4 or 5 constraints, that constraints and all, certain complex constraints we neglected. Only simple constraints we have taken into account, and we simply solved that problem. So that also there, if you if you go through the previous classes, then you might be coming across all these things. Okay, so the simple problem, one objective and two constraints, I think half an hour it might be taking. And that too, if the objective function is lengthy, then that is also very complex. Okay, if the objective function is, say for example, a simple example, f of x equal to x square. Okay, f of x equal to x square, that might be the objective function. So you need to substitute the value of x from 0 to 2 or 0 to 10 or 0 to 100, like that. Some constraints might be given. That is only one constraint and only one objective. So because the function is very simple, by substitution method, first you substitute 0, then substitute 1, substitute 2. If it is going high, then you have to substitute -1, -2, like that. Whatever the problem we have taken is very simple, like f of x equal to x square. If it is f of x is equal to x squared plus some cosecant squared of root of b squared minus 4ac, bracket close, then minus tan of some 1000 into 10 to the power of 10 to the power of 100, minus something. The objective function is going for one page. Say for example, the objective function is going for one page. Okay, the constraints also, some constraints they have given, some 0 to some crores or something like that. Some constraints also given. So you need to optimize that problem. Then what, in that scenario, what you will do? First you will substitute 0. then first you'll substitute 1, then next is 2, then next 3. We can't know which is the minimized function, minimized value of that particular function, that we can't know. So by substitution method, by substituting like 1 2 3 up to lakh and up to crores, so how many days you might be solving that problem? How many days? I think if you solve that problem, whatever the function I said, no, that is of minimum. So if it is 1 page or 2 page like that, how many days? Maybe 100 days, or throughout the year you might be solving that problem. That too, you can't able to find out the minimized value also. Okay, so this much complexity is there for a complex objective function. Okay, the objective function is simple, like very easily we can say x squared minus 3x, like that. It is also very easy. Or a x squared minus 4, x squared minus 3, that is also very easy. Within some few minutes you can easily solve. So this is of like if you take like your traditional methods like Newton method and all, very easy to solve, very easy to solve, and accurate answer you might be getting, accurate answer also you might be getting for this kind of function. If the objective is complex, then you need to then the solving by using normal method like a traditional method or Newton method. I think Newton method is one of the very accurate method. If you solve with the Newton's method of solving, I think Newton method also you studied in your mathematics 3. Okay, so that is the very accurate method to get the answer, but the time involved in that solving that problem is more. As I said, like 100 days or 200 days also you might be solving. And that too, you I think if you are solving 8 hours a day daily, I think it is not possible, like for manual calculation I'm telling. Okay, so if you go for some like optimization algorithms, so optimization algorithms, then the time involved, if you program in some programming languages nowadays, many programming languages are available, like MATLAB, then your Python programming, and previously C programming, C++ programming, like that. So C programming, I think it is one of the easiest programming. I think many engineering graduates or many science graduates or many technical graduates can easily program in C programming. Similar to that also, only the MATLAB programming also. Nowadays, latest they are going for your Python programming and all. So Python programming also similar, very similar to C. Some initialization, something like that. It is a number of lines and logic might be somewhat simple than the C programming. So nowadays, many of us are using this Python programming, and in a particular application we are going for MATLAB programming also. MATLAB programming also very easy, like the GI version of that MATLAB programming is very easy to understand, and very easy to program also, as like your Python program is somewhat simpler than your MATLAB program. Okay, so not very simpler, somewhat simpler than the MATLAB programming. So like if you program that optimization algorithm in your programming languages, so easily that optimization algorithm will easily solve that problem and tell the answer. Okay, so no need of waiting for if you're doing with manual calculation, it might be taking very much time. So this programming programming softwares and this algorithms is reducing the time, reducing the computation time. Okay, so what we'll do is we'll go for number of epochs, number of trials, like 100 trial runs or 50 trial runs, 200 trial runs, like that will go. And easily this programming itself will substitute 0 1 2 3 4, like that. If it is going more na, then it will substitute in the negative values like -1, -2, -3, like that. If it is nearer to the like a threshold value, sometimes it will be substituting in points also, like a point, minus point 1 or minus point 2. So accurate with that epochs, it will with that 100 epochs or 1,000 epochs, it will give you the accurate answer. So this might be the like optimized value for this function, like that accurate answer you will be getting. So if you program with the constraints also, okay, subject to constraints. So every optimization problem has some objective function subject to constraints. Okay, so if you program accurately the constraints also, so within that value, say for example 0 to 100, you have to choose that function value should be 0 to 100. So we have to get the minimized value, so it will be substituting like point 1, point 2, point 3, point 4, point 5, then point 9, 1.1 up to 99.999, like that it might be substituting. So whichever the value, the objective is less, that value it will show at the final within very less computation time. Even if you solve with your hands, it might be taking many days. But if you like, if the objective function is like 1 page or 2 pages, like that, it might be taking more days. If you continuously solving for 24 hours, then for 7 days or something, 10 days, then I think you might be getting not to, and that too not very accurate. So it will give you in very milliseconds or microseconds, like that, sometimes in nanoseconds also. It depends on the complexity of the your objective function. So in that scenario, you will get some accurate values while doing the programming. So that's why we are going for this optimization techniques, optimization techniques rather than your traditional methods. Okay, but in our class, we'll try to solve first with our traditional methods. Okay, traditional methods. Then the complex method will try to solve with some optimization techniques also. In the forthcoming classes, I'm going to explain you with that also. Okay, so now you understood what is yeah, objective function. So what is constraint? How to relate the objective function and constraints? How to find out the minimized value or maximized value? As I said, sometimes we need to find out the maximized value. We need to find out the maximized value rather than the minimized value. As I said, like in industry or any companies, their profit has to maximized. So in that scenario, if you go for the minimized value, then your problem is wrong. Okay, so in that scenario, you should go for maximized. Okay, sometimes the company objective might be of more in that the resources like less. Say for example, they will be having 0 to 300 employees. So within that 300 employees, we need to find out the minimized employees for that particular job, particular objective. Or sometimes with that minimum employees, how to maximize the profit. Okay, how many hours they need to work. Okay, so minimum 8 hours. So sometimes to attain that objective, sometimes 9 hours or 10 hours they need to work to for this many days to complete that objective. So constraints is number of employees, number of working times, number of working hours. Then and, like that, it might be increasing. Okay, so how much salaries they are giving, like that, it might be increasing to the problem. In power system also, if you take like say for example, economic load dispatch is one of the very like most important problem in your power system operation and control, and as well as your economic operation of the power systems. Okay, like if you're choose the optimal generators, if you choose the least cost generator, then only the as a whole the cost of all the generator might be reducing. So that is directly proportional to your tariff. Okay, so that also, if you like what we'll do is we'll number of generators, then directly proportional cost. Okay, so first generator this many crores, second generator this many lakhs, third generator this many lakhs, fifth generator this many crores. Okay, so now we need to choose the optimal generators based on the operating cost. So if you program, so I said only five, so you can easily choose among. So if it is 50, if it is 100, okay, choosing is so you have to compare with the first generator, second generator, what is the constraint, what is the objective, then what is the cost. Like that, everything you need to our human brain will not, even though it will do, it will take some more time. You need to compare first and second generator, then second and third generator, third and fourth, fifth, like that 100 generators you need to compare. Okay, so if you program, so easily you may get, so which is the optimal generators. So based on the cost, like that, within some microsecond, within some nanoseconds, you will get the answer. Okay, it depends on the objective. Like 100 means you will get in some microseconds. If it is 1,000 or 10,000, it might be taking some minutes, 1 minute, sometimes, like that. So it depends on the objective. So this is how you have to relate your objective function with your practical power system problems. Thank you.